That would be amazing. You've talked about this theory that the basic building block of everything in the universe could be information-like. This is more theoretical. How do you think about that, and what does that mean for a traditional classical Turing computer?
Well, look, I think you can, of course, all the famous, equals mc squared and all the stuff Einstein did, and energy and matter are kind of equivalent. But I actually think information has a kind of equivalency in the same way. So you can think of, the organization of matter and structure, and especially things like biology that are resisting entropy as basically information processing systems at their heart. So I think one can convert all of those three kind of quantities into each other, but I have this feeling information is most fundamental. So it's a little bit the opposite way around to the classic physicists thought in the 1920s and things, where, it's sort of energy and matter primary. I actually think it's a better way to understand the world, the universe, is to think about it as information first. And if that's true, and I think there's quite a lot of evidence for that, then of course AI is even more sort of profound in a sense than we think. And it's already pretty profound because it's also about organizing information and understanding information and constructing informational objects. So AI, in my opinion, is all about information processing. So I think there's something sort of very deeply connected with these different areas if you think of it through the lens of information processing as the primary way to think about it.
And do you think a classical Turing machine will be able to compute everything?
Well, I sometimes think, I sometimes sort of think about what we're doing and refer to ourselves as Turing's champion, because Turing machines, I think Alan Turing is one of my all-time, favorite scientific heroes. I think what he did obviously laid the foundations for computer science, but also AI. And I think it's one of the most profound results ever is the Turing machine result. Everything that is computable can be computed by a relatively simple description of a machine. So I think our brains are likely to be approximate Turing machines. And I think it's interesting to think about the connection between Turing machines and quantum computers and quantum systems. But I think at least what we've shown with things like AlphaGo and especially AlphaFold is that a classical Turing machine, obviously in the guise of a modern neural network, it can model what was thought to be, in the case of protein folding, it's a quantum system. At some sense, it's very, it's dealing with very small particles. And one might think you'd have to take into account all the quantum effects of the water bonds and all sorts of things. But it turns out you can get to an approximate optimal sort of solution on a classical system. So it may turn out that a lot of things that we think that would need a quantum system to model or run might be modelable on a classical system if thought about in the right way.
So you've talked about AI consistently as a tool, like a telescope or a microscope, astrolabe through the centuries. But when you think about a machine that can model almost anything, let's say it can't even model quantum systems, like you pointed out, when does it stop becoming a tool? And will that ever happen?
Well, my strong feeling is we should, in this sort of mission and journey to build AGI, those of us on that journey, many of people in this room, I feel like it would be best to build a tool first, an incredibly intelligent and useful and precise tool, and then cross the next sort of Rubicon. That's already profound enough. And has, of course, the tool could start becoming more and more autonomous and agent-like that we're all seeing. We're in the midst of that, the agent era now. But then there's a further step of like, does it have agency? Is it conscious? These sorts of questions, which are also going to be questions we're going to need to address. But I would recommend we do that as a second step, perhaps using the tool in the first step to help us with those next profound questions. And ideally also we could understand our own brain and minds better and define things like consciousness a lot more precisely than we can today.
Do you have estimations of what that definition of consciousness might look like?
No, I mean, I haven't got much to add beyond that thousands of years of philosophy